Good afternoon. We are going to take a look at applying what we've learned to different situations to solve more in-depth algebraic word problems. A lot of this is a carryover from what we've been doing in the last couple of days, and some of it is kind of a new strategy that you might be able to use. All in all, however, you're going to find that you're going to want to shortcut this, and I am begging you to please not shortcut this. To set up the situation the way that I am going to set it up so that in the long run you will be able to apply this strategy to other scenarios. Okay? So, the steps to solving an algebraic word problem. Write a let statement. That's what I've been saying for the last couple of days. Write an equation based upon the verbal model, what you've decided to be your let statements. Now, what it says underneath there, an equation cannot equal a variable, means you can't set your variable equal to your calculation. And you will see what I mean by this in a couple of minutes. But if you had x minus 8 equals 5, that would be correct. This is wrong. We'll solve the equation, answer the question that is asked, and because sometimes what we set up x to be is not what the answer wants. So let's say it said define the perimeter of a triangle and you just found the side, then the side is not going to be the answer. The perimeter would be the answer. And check that your answer is reasonable. So if you get $450 for an ice cream cone, you might want to go back and say something's not right and recheck it and rework it. Number 1, Shikenza's 8 years younger than her brother. She's 11 years old. How old is her brother? We know how old her brother is. Okay, we can do that math in our head. But what we want to do is show how we can set this up using an algebraic process. So what we need to do is we let x equal the person we know nothing about. Well, I know Shikenza's 8 years younger than her brother, so I'm going to let x equal the brother's age. Okay? And then I know Shikenza is 8 years younger than him. Okay? So what I'm trying to do is set up an equation that represents the situation. So the equation that represents the situation is that the brother's age minus 8 equals 11. Okay? So Shikenza's age is equal to the brother's age minus 8. So this is kind of like Shikenza, and this is the brother. Minus 8, okay? You're just trying to set up a situation that would allow you to solve the problem if you could not do it in your head, which I know you can do these in your head. So, let's look at the next one. Jeremy has 18 candy bars, so I'm obviously not solving for Jeremy's candy bars. I want to know how many candy bars Lucas has, and Lucas has, Jeremy has 3 less than Lucas, okay? So I don't know anything about Lucas, so I'm going to write Lucas's candy bars here. And I know Jeremy has 3 less than Lucas. And I know that Jeremy has 3 less than Lucas, and he has 18. I know some of you are thinking this is silly, and again, I'm just going to ask you to please bear with me, and we'll see how it goes. All right? So I'm going to let you guys finish 3, 4, and 5 there. And I'm going to talk about total problems. Total problems come in handy a lot because sometimes you feel like you don't have enough information. So let's look at the first one. Mondi has a hat and scarf. She bought a hat and a scarf and paid $56. If the hat was $35, how much did she pay for the scarf? So I'll just make the scarf's price what I don't know and I'm trying to find. And I know that the total paid was $56. All right? So let's say the scarf was 10, then the hat would be 46. If the scarf was 16, the hat would be 40. How am I getting that? What process am I using? I'm using subtraction. They both have to add up to 56, so this would be the money paid for the hat, and I know that the hat was 35. So 56 minus x equals 35. Okay, I'm going to let you guys do 8. So far you have number 3, 4, 5, and 8 to work on your own. I'm going to look at number 9. Zach swam the same distance Monday, Tuesday, and Wednesday. On Thursday, he swam 950 yards. If he swam 400 4,550 yards overall. How many did he swim on Tuesday? So I can let X equal the miles that he swam on Tuesday, or miles, sorry Zach, yards, okay? What he swam on Tuesday, which it also coincidentally happens to be Monday, Tuesday, and Wednesday, okay? And that's going to mean that overall he swam Monday, Tuesday, Wednesday, plus 950 equals 4,500. And you guys can go ahead and solve these. I'm just showing you how to set them up. All right, so you should be able to combine like terms and solve there to find out how many miles he swam on Tuesday. I'm going to let you finish up 10. And I'm going to talk about multiple let statements. Now, a lot of these you have done before. You've done a problem like 11. You've done, well, let's do 12 because that's kind of like a total problem. The sum of two integers is 18. If the larger is 3 more than twice the smaller, find the larger. Now, you could do this problem based upon the way we did number problems before, or you can do it using total. So I'm going to show you a different way rather than setting it up saying, you could set it up the way we did a couple days ago and say that x equals the smaller, and then 3 more than twice the smaller is going to be the larger, and then add them up to get 18. I'm going to show you another method, okay, just so you have a couple different strategies. So if I know the sum of two integers is 18, I can let x equal one integer, and then 18 minus x would be another integer, or the other, or whatever. Yes? So if the larger, let's say that this is the smaller one, and this is the larger one. If the larger is 3 more than twice the smaller, so I know the larger is 3 more than twice the smaller, find the larger. Okay, so I would add x to the right, giving me 3x, and I would subtract 3, giving me 15, and then I would get, oops, that's an x, equals 5. Okay? So I have 5 and 13. Let's go down, and I will do maybe 1 or 2 more for you. You can do these however you would like, all right? So I'm showing you a couple different strategies. I think what I might do here, is I will do number 15 2 different ways, okay? And that will show you. So Anthony spent $372 on household repairs. He paid the plumber 12 more than twice the electrician. How much did he pay each person? So the first way I'm going to do it is kind of like the total way. All right? And that's going to be like this. I'm going to let x equal what he spent on the plumber. So then 372 minus x would be the electrician. And then it says he paid the plumber 12 more than. He paid the plumber 12 more than twice what he paid the electrician. Twice what he paid the electrician. Okay? And in that case, I would get x equals 744 minus 2x plus 12. And if I bring the 2x to the left, I get 3x equals, simplify 744 plus 12, 756. And that is going to be 252 if you divide that out. So that means he paid the plumber 252, and if I subtract 252 from 372, I get 120. All right, so that's one way of doing it. Now I'm going to show you another way. You can see that you're just still going to get the same answer. All right, and then I'll let you guys finish the rest on your own. So I could start with this information, right? He paid the plumber 12 more than twice what he paid the electrician. So I don't know what he paid the electrician. I'm going to say the electrician is X. And he paid the plumber 12 more than twice the electrician. So that's going to be the plumber. Right? And so I know that he spent a total of, so all these guys together are 372. So I'm going to do x plus 2x plus 12 equals 372. 3x plus 12 equals 372. and 3x equals 360, and x equals 120. Yes? So I still got the same answer. I got the electrician is 120, and which would leave 252 for the plumber. Okay, and that would be my final answer. So as you can see, you could do it either way. Whichever makes sense to you would be the best strategy to use, but you might want to play around with it and try a couple different strategies. So you're off on your own, and I think I'll post the answers here for you coming up so that you can come back and check them. Okay? Have a good night. So I put up some of these answers for you. I'm going to kind of buzz through here. If you have any problems, we can easily go over them tomorrow. You can at least mark them, and then you will know what kinds of problems you're having. In number 3, I got 46 markers for James. In number 4, I got 15 miles for Jing Hao, and Z's Cat's 3.5 years old. I also got $64 for how much Danny earned. So you can pause here and look at a little of that work if you need to. I'm going to go forward and look at the next page. So number 10 was 405 votes. 11, the numbers are 15 and 30. This one kind of turned out interesting, number 13, where we had an infinite number of solutions. Okay, that's that old interesting solutions trick. 14, the coat was 120, the suit was 240. I didn't show work here. I would like you to bring in your work if you cannot get these right, because I think it's a good opportunity for us to look at them. So there are the last 3 answers, and hopefully you fared fairly well. Have a wonderful evening. I'll see you tomorrow morning.